First of all, I just want to say thank you so much for coming to Android Summit. We are very excited to have this year's version of Android Summit 2020 virtually. Like I said, we're all really, really excited. We've got a lot in store for you. Words can't really express how excited we all are. There's a lot of work that went into this year. As with most conferences, we had to kind of decide whether we were going to have it or not. And fortunately, we pushed through and decided, hey, why not? We've never done a virtual conference. Let's figure it out. So I'm really stoked. I know the team is really excited. I was going to say we should have some theme music, but we already did. So that's awesome. I think what we should do though is, hey, Johnny, can we unmute the entire audience and then just cheer? What do you think?
I would say, given the issues we've just experienced, maybe that's not a great idea on Zoom. So maybe later.
All right. Well, this is why Johnny's here, to keep me from doing something crazy. All right. But anyway, so that's the welcome. I want to make sure that all of you feel very welcome. Johnny, we go to the next slide. And first thing, Android Summit is about everyone here. This is an audience picture from one of our previous summits. And we're going to miss having everybody physically in the same location, but it's going to be really, really outstanding. And thank you all for taking the time today and tomorrow. We're going to go through a lot of different things. We have some logistics. We're going to say some thank yous. We're going to give some updates on some pieces of data, like how many attendees, how many speakers, and also how much money we raised for our charity, Women Who Code. And we're just really excited to have you. All right, Johnny, next slide. All right. This year, we are truly a global event. There was so much learning that went into how to actually pull this off. Normally, we start planning this in January. We usually lock down a venue, start putting out the CFP by probably May or June. And then we usually host in August. We decided in August to do this. So the fact that we were able to pull it together in a couple of months is just outstanding. And thank you all for coming today. Like I said, this year is unique. We're a truly global event. To recap, we are 2 full days, 3 sessions per day, 3 tracks per day, 39 speakers across 11 countries. There are a lot of speakers who are, it might be 10 o'clock, 11 o'clock, midnight their time. So thank you all very much for coming in and still submitting talks and still being able to be with us all the way through at least the West Coast. Quick update, we have, as of just a couple of minutes ago, we have 350 attendees. That is outstanding. That is one of our largest crowds we've ever had, and that is just great. Next slide, Johnny. First on, I want to give a shout out to our, one of the reasons we actually host this. We do this conference every year to help learn and grow our developer community in specifically the Android platform. But this is also a charity event. We do all money that comes into the Android Summit Eventbrite account goes directly to Women Who Code. Capital One has a very long history with Women Who Code. We've actually been, we have foundationally invested in their organization many, many times. And so I just wanted to say thank you so much to Women Who Code providing us this opportunity to work with you, and especially our Women Who Code mobile partners. I'm not sure everyone knows, but there is a fairly new-ish chapter of Women Who Code called Women Who Code Mobile. And if you are interested, I highly recommend you check out their website. There's a very informative page. And if you go to the next slide, Johnny, I have one special call out. Madonna, I know, is in the audience, and she and I have connected. We've had a couple of conversations online, and she has been just an outstanding partner, really helped surface this event within her and external communities. And I just can't say enough. Thank you so much. She is one of the Women Who Code mobile leads, and her Twitter account is right there. So Johnny, you wanna go to the next one? All right, real quick. I want to give a quick shout out. How many of you have met or know Michael, Toria, or Dan? Maybe just do like a thumbs up within the screen if you can do that. Michael, Toria, and Dan founded Android Summit back in 2015. And they were just kind of the heart and soul of this conference for many years. I've been here for about 5 years. Michael, Toria, and Dan started it. And the Android Summit organizing team has gone through some significant changes this year. These outstanding leaders, like I said, were the heart and soul of this conference every single year. And they have actually stepped back a little bit and allowed the next generation of leaders to take the reins and execute on this original vision and continue to grow it. They have set an extremely high bar. I hope that we can actually even come close to filling their shoes. And I just want to give a huge huge shout out and thank you to Michael, Toria, and Dan. And also, by the way, I added Michael's Twitter account to the bottom of the page because he has about 20 followers. He needs some extra love. I would love for you to go and a couple of us to go and follow him. All right. Let's see. All right. A little bit on the code of conduct. Pretty standard things here. It is really important to make this conference as awesome and an amazing event as we possibly can for everyone. Google ran an ad back in 2016, and it, kind of the theme was be together, not the same. We are all unique, and we all bring something special to every community or meeting or gathering. Feel free to share yourself, and also please be open and welcoming and courteous to everyone. If there happen to be any issues, please grab someone with an Android Summit, a green background like myself, send them a chat, and we'll certainly take care of it as best we can. Of course, I'm sure we won't have any of those issues here, but definitely wanted to call it out. There is a code of conduct linked on our website as well if you want to read a little bit more into it. Android Summit, of course, is our hashtag. I'd love for us to be trending. We have a huge group here. Feel free to tweet and hashtag either at Android Summit or at our hashtag. We appreciate it quite a bit. Swag. So you thought you weren't going to get any swag not going to conferences this year. Well, not Android Summit. Each of you should have received an email with a link directly to order your swag. The link is here, so screenshot it if you haven't already, or go dive into your email bins and make sure you order your t-shirts. We will be taking the final order probably in a couple of days and sending out that order, and you should get them within a week. They're really, really good t-shirts, so highly recommend you get them. Oh, and now the fun part. All right, trivia and prizes. Okay. So in our endless bid to get everyone to stay throughout the whole conference, we are going to have a Q&A trivia through Kahoot. I'm pretty sure some of you have used Kahoot in the past. At the end of each day, today included, and tomorrow, we're going to be giving away some outstanding prizes. You can see the list there. We're going to give a LeetCode subscription, a Google Home Max, one of the new Chromecasts with the remote controller. I don't know why it took Google 4 years to add a remote controller, but thank you. And actually 2 of the new Oculus Quests that haven't even shipped yet. So I'm sure we'll give one of those away today and one of those tomorrow. I think we're giving 3 prizes each day. So highly, highly recommend that everyone stay on. Also, pay attention to the sessions and keynotes that you're in. There might be some questions from your speakers that are included in there. So highly recommend. These are some of our partners. Capital One has, again, is our sole sponsor, benefits our Women Who Code team members. And of course, we have some partners. Our Google Developer Group, DC Android, MoDev has helped us, specifically devcommunity.org. If you've never been there, I highly recommend you go check it out. It's a umbrella organization for about 8 meetups in the DC area, and we have a newsletter and all sorts of things, and it was written in Flutter Web. So we'd love for you to come in and take a look at it. And the next one is, and finally, yes, our quick shout out, Capital One is hiring, yes, even Android developers. So if you are interested, please tap one of the Android Summit staff on the shoulder through chat, and we'll definitely get you connected with the right group. Most of the people on this, in this team with the green backgrounds works on the flagship app for Capital One. We have about 25 million active users per month. On the Android side, we are almost all Kotlin. No one writes in Java for the most part, but we've got most of the app written in Kotlin. And what's the other one? Oh, and if you join our team, you might be able to work on the next Android Summit. And with that, I am going to hand it over to Johnny to go through logistics.
Awesome. Thanks, Jared. I'll be quick. I know you're not here to hear from me, but I just want to reiterate what Jared said. Thank you all so much for joining us. Definitely a different experience having a virtual conference this year than in person. So what we want to do is make sure that you have the best experience virtually. So I want to go through some quick logistics. All of the sessions are available on Imamo. If you're here right now on this call, I know that you've already been there and you already know where to find the links. But it'll be the same process for every session throughout today and tomorrow. Be sure to go on there. You can create your personal schedule as well, and you'll get a helper email tomorrow morning that gives you all the links in one spot for the sessions that you've decided you want to go to. In addition to that, we have a Slack channel. So I'll talk about that in just a second, but all of the Zoom calls are going to be recorded. So it's good to know that going into it. We will post these on our YouTube channel sometime in the future after we have time to go through and edit them and make them look nice. Each of the Zoom rooms will have a room host who is one of the Android Summit staff there to help in any way that we can. So if you need assistance while you're in the Zoom call, reach out to that person and you'll know them by the green background that Jared mentioned. Q&As, the way that we're doing Q&As for all of the sessions by default is through the live chat. So using the chat function in the Zoom call, you can post your questions there. If a speaker decides that they want to enable folks to unmute themselves and ask their questions live, they can do that. But it's on a case-by-case basis. By default, it's going to be in the live chat. If you think of a question later or you want to reach out and talk about a topic post a session, we do have our Slack channel. The Slack channels, which I'll on the next slide show you how to access. There's a channel specifically for each session, and you can see the naming convention here. If you're on Imamo, on the bottom left, you'll see there's a tag, and that tag matches the Slack channel for that session. You can go in and ask questions. If you need support, two ways to do it mainly. Slack, if you didn't get the emails or if you haven't read your emails yet, go check. There's this link in the email as well, or take a screenshot. Join us on Slack. You can ask your questions there, hang out and socialize with other attendees, and just be part of the event. Zoom, I already mentioned we already have green backgrounds. All right. In addition to all the speakers, we have a few special sessions. You'll know these because the speaker for those is the Android Summit team. You're in one of those right now. There's also, at the beginning of each day, you'll notice on the schedule, a hallway track. That's just an open Zoom call that anybody can join if you just want to hang out and talk to folks. We also have closing remarks, and at the end of each day, trivia and prizes. If you want to win something, one of the things Jared talked about, that's where you do it. All right, I am done. So now it's time for why you're actually here, our keynote. So I'm super excited and honored to be able to introduce our keynote speaker, Chet. I'm sure everyone on this call probably already knows Chet. You've seen him in lots of places, including previous Google I/Os, the Now on Android video series, podcast, blog, Twitter, guys everywhere. And so we're super humbled that he's able to join us today. And so with that being said, I'm going to be quiet. I'm going to turn it over to Chet and let him talk to us. So Isaac, can we switch the screen share to Chet, please?
Hey, everybody. I bet I need to share my screen again. Is that right?
Yes, sir.
Let me do that. All right. Hopefully I'm sharing the right tab and not the Netflix movie that I'm in the middle of. All right. Let's do this thing. I'm going to assume that this is actually working. So this call started about 25 minutes ago when step one was I realized I didn't have a Zoom link. Step two was I realized I didn't actually know how to get a Zoom link. And so I started sending out panicked messages to everybody. You all probably got one from me. So fortunately, I finally got the link that I wanted. And then Zoom decided that it wasn't going to work. So then I used the best knowledge from the IT crowds. Have you tried turning it off and on again? And so I restarted Chrome, and that didn't do it. And then I had to reboot my system. So big panic getting into here, but finally we made it. So I am glad to be here again. I was there in person last year. It's great to be in person this year. I have to say DC looks a lot different than it did last year. It looks a lot like my office, but it's nice, comforting. It feels like home. You know, I have always thought DC felt like home. Thanks for having me. I'm going to get right into this because here's my process for creating presentations. I think, well, here are the things that I want to describe, and then I write a bunch of slides, and I think, I wonder how long this is going to take. And then I find out when I give it, and it turns out I usually write way too much content. And then the way to handle that, a professional presenter would then sort of carefully recraft the material and rewrite it and then rehearse it and time it and know exactly when it's going to come in. I am not a professional presenter. Instead, I just speak as fast as I can. I have a lot of content and I don't want to delay the next speaker. So I'm going to dive in and I'm going to rip really quickly through a lot of this stuff. So let us go. Modern Android development. I am Chet Haas. I'm on the developer relations team. I was on the engineering team for many years, since 2010 on Android. I am not Romain Guy. He just gave this talk with me at DroidCon EMEA right before this talk. So we're doing back-to-back talks, but he could not make this one. So if you want to imagine that he's here with me, just imagine an occasional French accent, and that's pretty much what you'd get. So modern Android development is a phrase that we've actually been using for a while. In fact, Romain and I gave a talk on the subject back in 2018 in Paris at Android Makers, and then a week later at Devoxx France, in Google I/O later that year, and then at the Android Developers Summit the year after that. We also gave the talk in Greece. I think we might have given it at DroidCon in London. So we've given something called Modern Android Development, but all of those talks were really about sort of comparing, you know, well, this is what we used to do, this is what we do now, this is what we used to do, this is what we do now. And to some extent, that's what I'm going to talk about, but really, we're using the phrase internally now to describe the surface area of things that we recommend that developers use, many of which are optional, but we think that this is how you should approach Android development now. If you've been developing Android for a while, then you probably are using API practices, tools that maybe are a bit dated, and maybe you should take a look into the broader world of Android development that should make your life a lot easier in developing Android applications and make your applications actually a lot better and more maintainable. And so that's what I want to talk about today. What is that surface area that we consider modern Android development? Before I do that, I want to talk about classic Android development. Here's a timeline. In 2007, late 2007, we came out with the Milestone 3 release, and that had a lot of the fundamentals, even in that early SDK release, pre 1.0, it had a lot of the fundamentals that we still use today. We were using the Java programming language. We had all these APIs in the platform for doing, you know, everything from storage to UI to graphics, whatever it was. We were using Eclipse with the ADT plugin at that time for the IDE for debugging and actually writing and building the code. And we distributed our applications with APKs. Well, we didn't distribute pre 1.0 since Market didn't exist. And then 1.0 came out in late 2008. Same stuff, but maybe bulleted, buttoned down a lot to make it more robust for future-proofing it as developers actually started writing and shipping applications on the platform. We spent many years developing more platform APIs, sort of playing catch-up at that time, building in fundamental capabilities that everybody would expect for smartphones at that time. In 2013, the first step toward what I would consider to be modern Android development was the introduction of Android Studio as the IDE for developing those applications. Then we introduced Kotlin support in 2017. A lot of developers, including a lot of you, were probably using Kotlin at the time anyway, but we would kind of break you with every tools release because we weren't really paying attention to it at this time. And then we started supporting Kotlin, which was really our way of saying, okay, we will not break you anymore. We agree that this is a fundamental part of writing Android applications. And so we supported it in a much more robust way. Architecture components is one of the major steps toward what I would think of as the modern Android APIs, these unbundled libraries that are specifically about making Android development easier. Then we introduced app bundles back in 2019, a new way of distributing applications from the Play Store that I'll talk about a little bit later. So one of the major areas in the classic world of Android development was the language. Of course, we came out with Java programming language. language support for many reasons. First of all, most developers actually used it. It's a great language for teaching in universities. It's language used on the server backend for web framework stuff on the desktop at that time. Like many people use Java, knew Java, so why not sort of take that knowledge and allow them to come to this new platform with patterns and approaches and syntax that they were already familiar with. Also, the tools for writing Java code were, for the most part, free, and free is, of course, the best price. So we wanted to make development for Android as approachable as possible, and so that price was really the right price for an IDE. There was a lot of existing libraries and middleware stuff that people could just bring over from their existing world and use as is, or practices that they had. So again, it sort of lowered the barrier of entry to this new platform. New APIs for people to learn, but at least they didn't need to learn new practices and language along the way. And also at that time, it was one of the new languages that offer this automatic memory management, so then you didn't have the headache of manually managing your memory correctly without crashing using traditional native languages like C and C++. On the tools front, previously we had Eclipse with the ADT plugin. Again, that was also free, pretty key to allowing a large developer base to tune into this platform. A lot of developers were familiar with it already. It was a very common tool being used for many things, including Java development at that time, so they could bring that development experience over. Again, it was free. That was really good. There was some amount of integration you could have for subtools. So if we developed a new capability, like we wanted to track allocations of memory or view the hierarchy or whatever it was, then to some extent we could integrate those tools directly into the IDE to have a common experience. And finally, it was free. On the API front, previously we basically had the platform APIs, right? So I was going to say every year, but no, way more frequently than every year, we would come out with a new platform release with stunning new functionality and bug fixes all the time. It was really frequent in the beginning. I'll show a timeline in a minute here. It's a bit amusing with today's eyes to see what was going on then. There was a lot of really important functionality in every release as we played catch up to fundamental new capabilities that everybody needed on these devices, and bug fixes happening all the time because the team was running really fast. There would be issues, they would fix issues, new platform release, and the treadmill just keeps going. If we look at the timeline, so back in 2008, we had 1.0, quick follow 1.1, the Petty 4 release, and then we had Cupcake coming in, Donut toward the end of 2009, 2.0 came in, and you can see how frequent these things are. The team was actually working generally on 2, sometimes even 3 releases in parallel just to get these things out, because these new device capabilities, new manufacturers coming online, new stuff that developers needed, new fixes that were really important, whatever it was, drove these releases at a really manic pace in the early days. 2.2, 2.3, Gingerbread, and then finally we settled down into what is now an annual cadence pretty much, which everyone breathes a sigh of relief. Manufacturers find it easier to consume these things on an annual basis. The platform team certainly appreciates that, and developers and users as well. Like, you don't need that many more releases. After we played catch up, all the stuff is there. The changes are a bit more incremental, and so why don't we take a little bit more time baking in the capabilities that we need and the fixes that we need in every platform release. On the distribution side, we had the Play Store. You would upload an APK, which is essentially a zip file of the resources and the code that you need for your application. And as we built in more capabilities into the platform for more configurations, more form factors, different screen sizes, locale support, then you would fold in that support for these different situations directly into your APK. And there were 2 approaches that you could have. You could manage separate APKs. So you could have an APK that is specifically for people in this type of configuration and that type of configuration, that type of configuration. And then you kind of need to manage this large list of APKs on your own and upload these separately as separate applications. Or you could just have what we call a monolithic APK with everything that everybody would need that would then be much larger. So some of the problems that came about from these classic approaches, again, in these 4 categories that I talked through. On the language side, Java programming language, awesome language, and still awesome, but verbose, certainly in modern terms, takes a lot of code, a lot of boilerplate code to do a lot of things that we consider to be kind of trivial now. And so it ends up being a lot of code to write, a lot of code to maintain, a lot of code to read through when you're trying to understand what's going on. On the tools side, Eclipse and ADT was really powerful and everybody knew how to use it, but it was difficult for us to customize. We wanted to make a really good tool for our developers, but we did not control that core framework. It was difficult. It was possible to integrate subtools in there, but it was difficult to customize those. And so we ended up having a lot of separate tools with inconsistent UIs, either inside that tool or sometimes we couldn't integrate them. And then there were standalone tools just because we didn't have the capability to make it all a nice integrated experience there. The IDE was a really powerful IDE, but then they sort of reached the goal that they had for at least Java development, and then they would focus on other priorities for that platform, or maybe some companies would spin out entirely and not be working on it. And so we weren't really getting active participation in the areas of the IDE that we needed to continue making it a better and better tool, and we had no control over the experience. So many times I would go to the tools team and say, hey, wouldn't it be nice if we could do this thing instead in ADT? And they said, yes, that would be nice, and we can't, because that depends on core infrastructure that we do not control. On the API side, we did have that approach of having all of the APIs in the platform, but the developers were limited in terms of what they could take advantage of by what their users could actually get. So they were not very motivated, you were not very motivated to take on new functionality and even new fixes, knowing that your users won't get that functionality for some number of months or even years, depending on their situation and the devices in the wider world. Also, a lot of the APIs were somewhat complicated. Now, some of this I think is totally valid because it's a really complicated situation, right? This is not, we're not writing a command line utility here. We're writing an application that can take advantage of local storage, cloud storage. It can handle network, it can do messaging, it can do video, it can do graphics, it can do 3D graphics, it can handle, you know, offline operation, online operation. Like, there's so many things that you can do. And so it's kind of complicated. How do you figure out how to do all these things? And this is happening on, you know, devices with unpredictable behavior in terms of how fast is that CPU, what are the dynamics of the device at runtime, what are the dynamics of the network, like are you offline, are you online, can we depend on that at all? And so there ended up being complicated mechanisms like lifecycle, knowing when your application is actually in the foreground, the user is using it versus in the background, it's paused, it's resumed. Storage was a bit complicated, navigation, just going through the screens of your application was tricky. And a lot of those complications then embedded themselves in the APIs and the things that developers needed to understand in order to write these robust applications. On the distribution side, APKs were powerful and pretty simple. It is just a zip file. But then developers would end up having these monolithic APKs that all developers, all users would get, right? So you embed all the configuration locale possibilities that everybody needs. Well, that means that every single one of your users are going to get this larger distribution bundle because that's the only choice they have. Or you could split it up into separate APKs, and then you have the management nightmare of managing all of these things and keeping track of this stuff over time. So our answer increasingly in the last couple of years is what we now call modern Android development. And I wrote some words down to describe this thing, and I will just go ahead and read that because I think this is a pretty good summary of it. Development tools, APIs, language, and distribution technologies recommended by the Android team to help developers be productive and to create better apps that run across billions of devices. So you can see the 4 areas there that I talked about already, and I will talk about those in terms of modern Android development: tools, APIs, language, and distribution. So let's go. So when we talk about it internally, we talk about these pillars of modern Android development. So of course, me being an engineer, I think of it in terms of like a visual that actually has pillars. I don't think I was intended to take it this literally, but I did anyway. So here it is, modern Android development, sitting on the pillars of language, tools, APIs, and distribution. Then underneath that is the foundation layer. I'm not going to talk about platform. I assume you're using platform. I assume you're using core play technologies like the console, like Vitals. Let's just take that as read, but then let's talk about these optional pieces on top that we think that you should be learning and using if you are not there already. First of all, on the language side, use Kotlin. So Kotlin Timeline, the 1.0 release, they were working on it for several years before this. 1.0 came out in 2016. As I said, a lot of Android developers are using it at the time, and they weren't very happy with us because we would break it frequently in our tool support. And then finally, we officially supported it. Life got a lot better and easier, and adoption really kicked up at that time. At Google I/O in 2019, we went Kotlin first, meaning that a lot of the development that we're now doing in some of the unbundled libraries is actually using Kotlin and exposing APIs that make it easier for Kotlin developers. We also offer lots of training materials for people to spin up on actually learning and using this thing that may be new to them. Earlier this year, we started recommending coroutines as the preferred approach to asynchronous development, just making it much easier to write code that is inherently asynchronous. So coroutines, and then more recently, the flow approach. And this is kind of where we're at now with Kotlin. There are a few reasons that we recommended it. Expressiveness, basically having to write less boilerplate that we all know from other languages. You can just express things much more concisely with Kotlin. Type safety allows much more robust code, so you can actually embed the information that you know about the code in and catch errors at build time. So you can say, this is a nullable object, and then the compiler can actually check whether you're accessing the value of that thing without doing a null check first. Or you can say, this is non-null, and then it can check whether you're actually passing in parameters there that are obeying that contract, and it can flag that as a build warning or a build error that you can fix now instead of your user finding out about that bug later at runtime in the field. Interoperation with Java was really key. Whenever we talked to developers about integrating new languages into the platform, the answer was always, no, we don't want that. We have enough to do without thinking about you switching languages on us. Oh, unless it's Kotlin, because Kotlin integrates really nicely with everything that they now have. Integrates nicely with some of the development patterns that they've been using over the years with Java anyway, and certainly integrates nicely with all the platform APIs because it is really built on top of it. So interop was really key to us even considering Kotlin, much less adopting it. And then finally, structured concurrency, the ability to do this really complicated programming where asynchronicity is really built into the patterns that we have in the platform as we need to do constant call outs to other threads. So if you're on the UI and you want to access the database, you need to do that somewhere else. Well, then you need to have this asynchronous mechanism to get onto a different thread and then have a callback later, and it ends up being very complicated and causing very complicated code as a result. And structured concurrency is a way around that. It makes it much easier to write and read and maintain the code as a result. So if we look at a little bit of the code, we can see some of these features and more. First of all, the ability to have nullability directly in the language. So we can say this argument could be null, and then the compiler can check our accesses of that parameter in the code and flag that as a build error if we're doing the wrong thing. We have lambdas. Lambdas are not new for Kotlin, but the way that they're integrated in the language is quite nice. If it is the last parameter in a list to a function, then you can actually pull it out and put it inside this curly brace scope to make it much easier to read. It's just a very elegant expression of the code that you want to execute there. Extension functions are my favorite language feature. It's the ability to sort of push APIs in an indirect way directly into where they logically live. So if I want to add a new method to the string class, well, I can't because I don't own the string class, right? Somebody else is responsible for that API. But in my library, in my application code, I can essentially add this extension function, then make it look like that capability is being executed in the context of the string class, which just makes for a really elegant and very readable approach to the resulting code. We have template expressions, which make it much easier to format strings and also to have all of this logic type check by the compiler at build time. And then finally, properties. This is obviously not all the language features, just some of the highlights here. But the ability to always access via this sort of, very concise field access, but underneath there are getters and setters. It's not the by contract mechanism that we have in the Java programming language, but rather the explicit notion of having properties that are always backed by getters and setters. So another reason that we chose Kotlin and that we love Kotlin and that we recommend the developers look into this on your own is speed. And by speed, I'm not talking necessarily about runtime speed, but rather development speed, the speed at which you can actually write and maintain your code going forward. Also, the speed of development of the language itself. The time it took for that team in JetBrains to come up with a notion of coroutines, then embed it in these experimental versions, and then push it as a language feature was really quite impressive. And they're coming out with new features and functionality all the time. It's a really actively maintained and developed language that has all kinds of capabilities coming in all the time that make it more powerful for us developers to integrate with and to use. There's been great uptake so far. I mentioned some of this already. So a lot of professional Android developers are using it already, and we've looked around and seen that over 70% of the top 1,000 apps, I believe this is on the Play Store, contain Kotlin code already. So a lot of you are probably using it already, and I guess what I have to say to you is great. Good for you. Kotlin initiatives. So there are a lot of things that we're doing. So it is a language that is developed and maintained by JetBrains, but we work closely with them. And we do a lot of things to make it even better for Android developers. We develop these lint checks. We have a dedicated compiler team that works on everything from optimizations for the R8 compiler to improving annotation processing speed. We add annotations to platform APIs to make it easier for Kotlin developers. So when we add these annotations, that means that if you are calling those platform APIs, they're APIs in the Java programming language because all of the core platform APIs are. But we can add these annotations, and if you're writing Kotlin code and you're calling that code with parameters that are not obeying the contract of what those APIs are expressing, then you will get a build error or a build warning. If we are adding a new annotation, we add it as one of those recently annotations, and that means you're going to get a build warning, and you should really fix your build. Otherwise, if that annotation was already in there as recently, we may upgrade that to nullable or non-null. And if you're calling that with the wrong code, then you will get a build error. And not only should you fix your code, but you have to fix your code. And honestly, you should fix your code anyway, because you would really rather catch and fix that at build time rather than runtime on the user's device. We also are working on Kotlin extensions library. This is sort of functions that you can think of as syntactic sugar, just making it a lot easier to use our APIs. For backward compatibility reasons, we're not going to go in and sort of recraft a lot of the APIs on an ongoing basis, because then it just gets more confusing because you have all the old stuff and the new stuff that we're doing instead. Instead, we have these KTX functions sort of sitting alongside the library to just make it much easier to call a lot of the APIs and core functionality. I'm going to take a really quick look at an example here. So let's say you want to take the contents of a drawable and draw it into a bitmap. Then you're going to deal with a couple of the core APIs here. You have the bitmap API where you create it with a given width and a height and a configuration. You have this drawable API, draw. You're going to create a canvas, and then you're going to draw with that canvas. And the resulting code looks something like this. You need to get the bounds into the right values there, and save out the old ones so you can restore them later. You're going to create that bitmap with those 3 parameters. Then you're going to create the canvas and draw into that canvas, and then restore the bounds. We offer a KTX command that looks something like this: to bitmap. It takes 3 parameters, all of which have default values, right? And so if those default values are correct in your situation, then you don't need to call it with anything. In particular, that last parameter, almost all the time people are going to call it with ARGB 8888. So why don't we just assume that, and then you never have to use that. So the resulting code that you need for actually drawing that drawable into a bitmap looks something more like this. Right? So this is the code internally that this function implements. So it is syntactic sugar, but it's really nice and logical syntactic sugar that you can take advantage of. So there's KTX APIs across the spectrum, all kinds of APIs that you can take advantage of for simplifying your code. Some of the initiatives that we have around Kotlin includes APIs that we've crafted Kotlin specific capabilities for, including APIs in Room and Work Manager. Paging 3 went through a complete rewrite in Kotlin. to use coroutines and flow for what is essentially an inherently asynchronous operation anyway, taking that data from the database and getting it into the recycler view. That is currently in alpha. Jetpack Compose is the future UI toolkit for Android written in and for Kotlin. It uses a Kotlin compiler for a lot of its core functionality, Kotlin compiler plugin. So really takes advantage of a lot of the language and platform capabilities to make that a much better programming experience for UI. Lots of docs and training, lots of outreach stuff that we do to help people learn and use Kotlin going forwards. And that is on the language side. Now let's talk quickly about tools. Android Studio, obviously the IDE of choice. The tool was first introduced in 2013. Then we introduced the Constraint Layout Editor, important tool for UI development. And we also deprecated Eclipse ADT at that time. It had sort of been on maintenance mode for a while. And then finally in 2016, we said, you know what, the time is really ripe. You need to use Android Studio. And then we just kept introducing powerful tools as we went. So we introduced Kotlin support. We also introduced a suite of profilers, CPU, memory, network profilers came online at that time, all using sort of a common framework and UI to make it easier instead of having these separate tools everywhere doing different things. We introduced the new DEX compiler for compiling DEX codes. Systrace, more profilers, so Systrace, so lower level profiling information for what's going on in the CPU for your application, as well as energy, battery profilers. Navigation editor, this is an important point. When I talk about tools, yes, we're introducing these sort of standalone things that we think you should use, but a lot of the focus of the tools team is actually on building tools that integrate well with a lot of the modern APIs that I'm talking about. And navigation editor is one of those things. The API was developed in conjunction with the tool, so we expect that when you write navigation code, you're actually going to be using both. You're going to be using the tool to design the experience and then the code to actually implement the results of that design. View binding was introduced earlier this year. As a much simpler and less tedious approach to get view by ID. You can think of it as a simplified data binding that is specifically about getting the view ID. And then motion editor, just like navigation editor, the motion layout was really written in conjunction with the tool. So finally in 4.0, we released the design tool, making it a lot easier to design these transitions where you could really customize the animations that take you from the before to the after state in the UI. There's all the core capabilities in IntelliJ that we take advantage of at the same time, like all the refactoring capabilities. This UI that really is quite extensible. I no longer have the problem of going to the tools team and asking for them for a thing and them saying, yeah, we don't have control over that. No, they do. They have really good control over our experience of the plugin that we have for IntelliJ that makes Android Studio. So there's been more and more effort of creating new tools that are easily integrated into there, and some external tools, like we had things like Systrace that also exists. A more powerful version of Systrace exists as a standalone tool, but we took a lot of the core capabilities of Systrace and integrated it directly into the IDE. There's all kinds of developments that are going on, not just by JetBrains, but also by us, and some of those in conjunction, such as working with their compiler team on some of those improvements. Tight integration in the tool between Kotlin, Gradle, of course, all the lint checks and the quick fixes that we're adding over time, and integration with existing and new APIs. As I said, a lot of the tools experience is not just about using the tool itself, but rather using the tool in conjunction with the APIs that we're developing at the same time, such as navigation and motion layout that I talked about, the data binding work there, all the layouts, powerful stuff going on in their room, database visualization. So just all kinds of new capabilities in the tool that are really meant to integrate between, it's not just about designing an experience, it's about designing an experience that you then have APIs to take advantage of in your code as well. On the API front, I'm talking about APIs in Android Jetpack, but specifically a subset of those APIs. Jetpack is over 80 libraries. They're all great libraries. All of my children are my favorite children. But when we talk about modern APIs, we're really talking about the subset of those libraries that are specifically intended to make your life easier in developing Android applications, especially for some of the more complicated parts, inherently complicated parts. So if we look at the API surface for modern Android, I think of it in these terms. So first of all, I think the first addition was constraint layout when that came out in 2017. Then all the architecture components started coming out later that year. Then we introduced more architecture components the following year at I/O, paging, navigation, work manager. Material design components came online. This made it a lot easier to integrate the concepts and the look of material design without basically figuring it out on your own. Like, well, there's a material spec and good luck. Instead, we have this MDC library that makes it much easier for you to just take those rich components that embed the ideas of material design directly inside of them, make it easier for you to develop applications using those components. Then last year, we announced Jetpack Compose and developed that in the open. That was pre-alpha until I think it was August, and now that is in alpha stages. And we also introduced Camera X. We'll see a little bit about that later. It makes it much easier to develop camera applications for the wide ecosystem of devices that we have. Oh my gosh, that is the time. I am really running low on time. Let's keep going. Motion layout and motion editor, those, as I said, were developed in conjunction with each other, the API as well as the design tool. That's an important part of this going forward as well. Constraint layout, I think of this as relative layout on steroids. It's really about being able to create this rich layout where things are positioned relative to other things on the screen, but you can also create these virtual groups now that make it much easier to design these experience or lay in key lines, these guidelines, so you can make padding and margins much more consistent across the grid of your application UI. Motion layout is a subclass of constraint layout that makes it easier. I think of this as transitions on steroids, where you can not only have the before and after state and an automatic animation that automatically takes you from one to the other, but you can define the experience of that animation, and you can interact with the user at the time too. The user can be scrolling a list and essentially scrub that animation between the before and after states, creating these really rich experiences. Life cycles, you used to need to understand something like this, actually even more than this, and you used to have to override a bunch of methods in activity or in your app-compat activity subclass, which ended up embedding way too much code into your activity class. That was not the intention, but what else were you supposed to do? So this is not the approach that we recommend. Instead, we have this concept of life cycles in the APIs of modern Androids, where it's about observing the changes. So you don't have to override those anymore. Instead, you can get messages back into your code when things change, or you can even query it at any given time saying, am I in the pause state? Am I in the start state? This makes it much easier to separate the concerns in your application where you have the UI code that does not directly manage the data, and you have the data code which does not directly manage the UI code. Instead, you can observe changes on the data, and when changes occur, you get a callback and you can take the appropriate action on the UI side. The data is probably backed by some sort of database, so you have the SQLite thing there, and maybe you are wrapping it with a DAO using the Room API, and Room the DAO comes with these built-in suspend functions using coroutines from Kotlin, makes it much easier to then foist that work onto another thread. This is especially important for Room and database interaction in general, because what if I'm in my UI object and I need to write to the database? Don't do it on the UI thread, and then that ends up potentially creating spaghetti code to get onto another thread and then do the operation, then come back later and do something else with it. So coroutines and the suspend functions here in the DAO interface make that much easier. Let's see. A lot of these are also built to work together, where the APIs were developed in conjunction, and everything is now lifecycle aware, including new things like Camera X is lifecycle aware as well. I should also point out that if you're using RxJava, the intention was not to get everybody to switch from RxJava. It's not a complete replacement for everything it does there. Rather, it has some similar capabilities that may be easier to integrate if you're not using it already. But if you're using RxJava and you're happy with it, that's fine. We also have APIs that we built into the libraries that make it easier to integrate with existing RxJava code. On the navigation component side, we have this nice library that makes it easier to define these flows within the screens of your application. You can design that. You can also edit it in XML, because usually there's XML that backs all the design resource that you create in the tool. And then you call it from code. So you design the resources over here that defines the destinations and the actions that take you between them. And then in the code, you say, I want to navigate to that destination. There's a lot of capabilities have been added to navigation, safe args for type safe, and much easier passing of bundled data between these destinations. Makes it much easier to define these single activity UIs instead of the traditional Android multi-activity, which is not as nice a user experience. It handles up versus back navigation in a much more consistent way and more automatically for you. And it also supports dynamic features. So even if you want to navigate to something that is not yet downloaded and installed in your application, you can navigate to that reference, and then underneath, navigation component will do the right thing to download and install it and navigate to it for you. I'm going to walk really quickly through this because my clock says that I'm about to bump into the next session time. Work Manager makes it much easier to do deferrable work. I want to walk really quickly through an example. So let's say you have an image, you want to do 3 different filters. Those can all happen in parallel. Then we want to compress it, and then we want to upload. We can have different constraints for each of these. I only want to filter if the battery has enough energy to actually do that. I only want to compress it if there's enough storage on the device, and I only want to upload it if I'm on an appropriate network at the time. So we can define the work that we need to do. We can define the constraints. So this is a constraint that says I only want to do it when the battery is not low. And then we can hook those up and say, okay, do the work with these constraints. And then we can schedule how these things happen. So we can run some things in parallel, or we can also execute them sequentially as well. Camera X, as I said, is a way for writing much easier camera applications, especially across the wide ecosystem. It turns out that a lot of the devices out there have different camera capabilities, and then applications would have a hard time dealing with this. They would say, well, try this approach, but if I'm on this particular device class, then do this other thing instead, and you'd end up having workarounds in your code. Camera X takes those workarounds and integrates them directly into the library and has this huge testing lab where they can run across a vast amount of the devices that are out there in the real world. And they have this simplified UI that really focuses on the core use cases that developers needed. We can take a look at some really simple code. You can basically say, I want to capture this image here, take a picture. I'm going to integrate with the lifecycle stuff, making it much easier to open and close the camera without forgetting to do that and causing undefined problems. And then I want to take the picture. So fairly simple approach to camera developments that again integrates with the vast array of ecosystem of devices out there. And we release these things frequently, really frequently. Every couple of weeks there's like incremental releases to many of the libraries out there. And there's new development, new APIs in development all the time, including the Jetpack Compose stuff that I talked about, Hilt for dependency injection, Paging 3 is currently in alpha, and on and on. Android App Bundle really quickly, and then I'll close up. This is the new way to distribute applications. We announced it in 2018. Think about it this way. A lot of users really don't have much storage. If they don't have much storage, then they may uninstall your application to make room for another application instead. And that means that the larger your application is, the more likely it is to get uninstalled. Also, the larger your application is, the more likely it is to have problems when downloading and installing in the first place. Also, we've seen data that essentially the smaller your application is, the more likely it is to get installed. It is one of the factors that users use when choosing applications to install. You can think of app bundles as being the monolithic APK where the Play Store can then create the optimized APK specific to a user's runtime device. They know what the runtime characteristics of that device are, what the configurations and locales are that that device supports, and then they can optimize and come up with the APK that makes sense for them. There's been pretty good adoption of app bundles so far. and better all the time. And most importantly, automatic size savings for you, an average of 20% size savings just from that optimization of this monolithic app bundle down to the APK that the user actually needs. So if we take a look again at my literal pillars, and we talked about language. On the language side, we have Kotlin on tools, obviously Android Studio. On APIs, everything from architecture components to constraint and motion layouts. The Camera X API currently in beta, and material design components. And on distribution, Android App Bundle, I should point out too, in the second half of 2021, there's a requirement. So app bundles are optional now. We do recommend that you check them out and use them, but it is a requirement that new apps coming out in the second half of 2021 will need to use app bundles, so check them out. And also check out Modern Android Development. There's a site with more information about all of this stuff on d.android.com, and that is it. And I'm late anyway. I tried really hard and I'm late.
Awesome. Thanks, Chet. Appreciate that. And you're not that late, to be honest. We started a little late, so 3 minutes is actually quite respectable. I think that's it for the keynote, everybody. So at this point, the next session start at 10 after. So head on over to Imamo if you haven't already. All the links to all the sessions are there. Pick the ones you want to go to, and we'll see you hopefully at the end of the day for the first trivia and prize giveaway. Thanks, everybody.
Thanks.
Thanks, everybody.